assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Right, we're asked to write an equation for the formation of each of the compound from its elements in their standard state and find the delta H of the reaction. Well, look at the first one, nitrogen 4 oxide, NO2, right? The equation would be nitrogen gas plus oxygen gas, and we would have NO2. This is from their elements in their standard state, but we have to get it balanced, right? And it's enthalpy of formation. So only 1 mole of this. So we're going to make this half, right? We're going to make this half. And now the delta H of the reaction, right, is going to be the total enthalpy of the product minus the total enthalpy of the reactant. So if you look at the table, right, you would find that the enthalpy of formation of NO2 from the appendix, so the total enthalpy of the product is equal to the enthalpy of formation of NO2, and that would give us what? 33.10 kilojoule, right? While you will see that for the reactant, the enthalpy of formation, standard enthalpy of formation of nitrogen gas, there's half of that, plus the half of the enthalpy of formation of oxygen gas, right? You're going to find this to be 0, right? If you check that, you'll see that it is 0 for nitrogen gas and for oxygen gas. So at the end of the day, the delta H of the reaction is just going to be equal to the enthalpy of formation of nitrogen dioxide. And that's going to be plus 33.1 kJ. That's the answer to that question, right? So let's look at B. The B part, next one we have there is magnesium carbonate, MgCO3. And this would be magnesium plus carbon plus oxygen gas. And we're going to have MgCO3. That's going to be the equation. Of course, like I said, we have to balance this. So this would be 3/2, right? Again, you see that this is in standard state, solid, solid, and this is gas, and this is solid. The delta H of this reaction, like what we did before, would be the total enthalpy of the product minus the total enthalpy of the reactant, right? So, and the total enthalpy of the product is the enthalpy of formation of magnesium carbonate solid, right? And when you check the appendix, you will see that that would give you minus 11 minus 111.7 minus 1111.7 kilojoules, right? That's for magnesium carbonate. You see that for the others, for magnesium solid is 0, for carbon is, for magnesium solid is 0, for carbon is 0, for oxygen gas is also 0. So we can just say that at the end of the day, the enthalpy of the reaction for this equation would be minus 1111.7 kilojoules, right? That's it. And then for the next one, ethyne, right? C2H4 or acetylene. So that's carbon, so it's C2H4. The equation would be that you have carbon in solid plus hydrogen gas to give you C2H4, right? Gas. You balance this 2, and this is 2, right? Again, that's the equation. Enthalpy of formation is always 1 mole. Remember, so we don't touch that. And the enthalpy of the reaction, this is gas, would be equal to the enthalpy of formation of ethyne, right? That's what we're going to have. And that would simply be, because just following the same route, that would always be, check the table, you're going to have 52.47 kilojoules, right? That's going to be the enthalpy of the reaction. And then finally, the last one for methanol, CH3OH liquid, right? The equation would be the reaction between carbon solid plus hydrogen gas plus oxygen gas, and we'll have 1 mole of ethanol liquid, right? We're going to balance this. It's going to be 2, and this will be half. At the end of the day, the enthalpy of the reaction, the heat of the reaction, will be equal to the enthalpy of formation of methanol. And when you check that, that's going to give you on the standard for methanol, you're going to have minus 200 and liquid methanol. Remember, it has to be liquid, so you are very careful. You also see gaseous there. So we're minus 237, minus 238.7, 8.7 kilojoules. That's the answer, right? So that's it. We have the equations and their corresponding heat of reaction. I hope that was clear, right? Simple. Remember, heat of formation or the enthalpy of formation or the equation for formation must always show only 1 mole, right, of the product.